code. The next example of code injection is even less obvious. We're going to be looking at template injections. So modern web applications usually use a templating engine. Popular ones are, for example, Twig, PHP one, or Jinja on Python, or Velocity on Java. And how do they work? Well, they have the simple functionality of the developer being able to specify a template. This here. This usually comes from a file, for example, and then within this template there are placeholders that can be filled with input the user, the programmer wants to be somewhere. This is good for dynamic pages because the username in this case, for example, can be different all the time. This is a PHP Twig example. Jinja is a common templating engine for Python, very often used, for example, in combination with the Flask web framework. Works exactly the same, so you give him a template. Usually that's a complete HTML site or a part of a site, not just a string. And then, this variable here should say username, not name. And then this variable in the template will be replaced by whatever the developer decides. So the problem here occurs when user input is mixed with template code. So imagine a developer does something like that. Welcome back. Username. The username will be included later. But also here to the template code he adds a footer, and this footer can maybe be modified by a user. Comes from the database or whatever. So what could go wrong? What could the user do? Well, as you can see, these placeholders are written in braces and curly braces. So what the user could do with his user controlled footer, well, he could open these curly braces for a placeholder, and as it turns out, Twig has a reference to itself, and the self object has a reference to the environment, the Twig environment. And in the Twig environment you can set a callback that is supposed to be called when a filter is being used that doesn't exist. So we just set this callback in case somebody uses a filter that doesn't exist to the PHP function exec, and then we call a filter that doesn't exist. In the same way, get filter ID. Now the filter ID doesn't exist, and what does Twig do? Well, it calls the filter callback with the parameter. The parameter is the name of the filter that was used that doesn't exist. So server side, what is done is exec ID. So in this way we can execute arbitrary code on the server again. Just to show you that this doesn't only happen in Twig, well, let's look at Jinja. In Jinja we can do something very similar. We open with curly braces. We use the config object, its class. In it is a function, but in Python everything is object. Would go into detail of Python internals, not relevant here, but in it is an object that has a reference to the globals object. These are the global variables, and in the globals object there's a loaded module called OS. It's usually loaded, import OS, and it has a function called popen. It's a pipe open that calls a program, in this case ls. And then we have the output of the ls command, and we can read this via the read function. And then again we have executed the command ls, and have arbitrary command execution on the server. Just because user input was supplied to the template and not via the render function. Okay, so does this happen in reality? This happens quite often. It's somewhat comparable to misused prepared statements and SQL injections that we're going to be looking at later. Well, let's look at a Java example. Well, the Apache Struts framework that is very commonly used has something called the Object Graph Navigation Language, which can be used for something like templating. So what you're supposed to do is, for example, in the Struts example app, they do this: add a message to the users, going to be displayed somewhere. The name of the message is MSG. And then we create a new action message. And what you're supposed to do is supply the name of a registered action message and then variables that are supposed to be placed in this registered action message. But what you can do, and Gangster added here is a resource key for predefined message. What you can also do is just use an action message and then supply a string directly, sort of like as in template injection. And this leads to problems. This leads to code execution, just as we have seen here with the templates. The problematic part in Struts was that the example application, the Struts example application, was doing this here, was doing it the wrong way. And as you probably know, developers usually look for example code rather than documentation. So a lot of applications had this wrong version in use. A working exploit for Apache Struts is, you can see here, it's available on GitHub. As you can see, it looks a lot like the template injection examples we were looking at. Gets an instance of something, it checks if the underlying system is Windows, and then it just uses a process builder. Process builder is very similar to Python's popen. And then it just executes the command that has been specified here and then copies the output to the output stream. So, as I said, a lot of applications did this wrong and had this vulnerability. They could be attacked with this exploit that was publicly available on GitHub. And this exploit was used to, for example, hack Equifax to gain remote code execution on their web server, on their web app, and from there on steal all the data of the Americans and some Canadians.